Sound travels at different speeds in different materials, and how quickly it travels depends on what that material is and also the material's density. So here's the formula that relates these things together. How difficult it is for a sound wave to travel through any particular material is called the material's acoustic impedance, and it's represented with a capital Z. So you can see that if a material has a higher acoustic impedance but the same density as another material, sound will travel faster in it. To see why this is important, let's imagine that there's a little bit of air there between the transducer and the person's leg. And I'm going to imagine I've just sort of zoomed in here. So this is air and this is the leg. Okay, so in comes the ultrasound wave, and when the air has got one impedance and the leg has a different impedance, and we just label these Z1 and Z2. Now, when sound passes from one material to another, just like with light passing into a transparent material, some of it's going to keep going into the leg, but some of it's going to be reflected. And how much is reflected depends on these two impedances. And this is the formula that tells you how much. Now, don't worry, this is on the formula sheet, so you don't need to remember it. So you need to know that the I0 there, that's the intensity of the original incident sound wave, and IR there is the intensity of the reflected wave. And here's Z1 and Z2 as we mentioned before. So you can see that the bigger this is, the more of the wave is reflected and the less that goes on into the leg. Now, remember, the reason you do an ultrasound scan is because you want these ultrasound waves to go into the leg, reflect off bones and fractures and things, and then come back again and then get back to be received by the transducer again. So this is bad. We don't want ultrasound reflecting off the outside of the leg. We need it to go in if we're going to get a scan. So you want this to be as small as possible. You want as little reflecting back as possible. And the way you do that is you want your two materials to have their impedances as similar as possible. Now, air and flesh don't have very similar impedances at all. So if you actually have a sound wave going from air into a leg, you're going to get a lot of it reflected back, and you're not going to get a very good ultrasound image. And this is why, as I'm sure you've seen, this is why they put, when you go for an ultrasound scan, they put gel on you, and then they rub the transducer around in the gel, and that's to get rid of any air between the transducer and you, and because the gel itself has a very similar, so if this was gel instead of air, its impedance is very close to the impedance of your body, and then you don't get very much reflected at all, and you get a good image. Okay, so here is a question 3, to practice all of that. And nice easy first mark there. The formula for impedance, as we saw, is density times speed of sound in the material. And so that means that its units are the units of density times the units of speed. And they cancel down to kilograms per metre squared per second, as we've been told. And then for the next bit, here's our formula for the fraction of the sound wave that's going to be reflected back again. Now notice it doesn't matter which material is number 1 and which is number 2 because we're squaring it. So it doesn't matter which way round we get them. I've gone for bone as number 1 there, muscle as number 2, but it doesn't matter. And that gives you an answer of 0.374. Now, they will let you have 37%, but why have I not written that? Because they didn't ask for a percentage, they asked for a fraction. But they're quite lenient here, they'll let you have either.